It's larger than Mercury. It has its own magnetic field. And beneath its frozen surface may lie a vast, global ocean. Welcome to Ganymede, the largest moon in the solar system, and one of Jupiter's most fascinating and mysterious worlds. In this episode of Infinity Beyond, we dive deep into the science of this icy giant and uncover why it's fast becoming a top target in the search for alien oceans. Discovered by Galileo in 1610, Ganymede is the third of the Galilean moons and the largest natural satellite in our entire solar system, measuring over 5,200 kilometers in diameter. That's 8% larger than Mercury, though only about half as massive. What makes Ganymede so remarkable is that it behaves like a planet, despite being a moon. It has a layered interior, with an iron-rich core, a rocky mantle, and a thick outer shell of water ice. But here's where it gets really exciting. Beneath that icy crust lies a subsurface ocean, possibly 100 kilometers deep, sandwiched between layers of ice. This ocean is thought to be salty, electrically conductive, and may contain more water than all of Earth's oceans combined. If confirmed, it would make Ganymede a leading candidate in the search for extraterrestrial life. But Ganymede's uniqueness doesn't stop there. Unlike any other moon, Ganymede has its own magnetic field, discovered by NASA's Galileo spacecraft in the 1990s. This field is likely generated by a liquid iron or molten saltwater layer within the core. It interacts with Jupiter's powerful magnetosphere, creating stunning auroras in Ganymede's thin atmosphere, shimmering belts of light that glow near its poles. These auroras also help scientists study the internal structure of Ganymede. When the auroras rock back and forth under Jupiter's magnetic influence, researchers can model how the moon's interior conducts electricity, supporting the theory of a deep, global ocean. The surface of Ganymede is a blend of two terrains: dark, older regions heavily cratered from impacts; lighter, younger areas marked by grooves and ridges. These features suggest tectonic processes where surface ice cracked and shifted, possibly due to subsurface movement or tidal heating from Jupiter. One theory proposes that the ice shell periodically shifts or overturns, cycling fresh material to the surface. This could explain the relative youth of some surface features and supports the idea of cryovolcanism, icy eruptions that release slush or water. Ganymede also has a very thin atmosphere, composed mostly of oxygen, but it's far too tenuous to breathe. However, it's another piece of the puzzle that makes this moon resemble a frozen Earth on a grand scale. To explore Ganymede's secrets, the European Space Agency, ESA, is preparing the JUICE mission, short for Jupiter Icy Moons Explorer. Launching in the 2020s, JUICE will conduct multiple flybys of Ganymede before entering orbit around it, becoming the first spacecraft to ever orbit a moon other than our own. Its mission: to map the surface, probe the ocean beneath, study the magnetic field, and assess the potential for habitability. JUICE will carry radar instruments capable of penetrating up to 9 kilometers into the ice, allowing scientists to detect subsurface features. It will also analyze surface composition, temperature, and structure, helping determine whether Ganymede could support microbial life. But Ganymede isn't just important on its own. It also plays a critical role in the broader Jovian system. Its gravitational interaction with neighboring moons, Europa and Io, creates orbital resonances that help maintain tidal heating. This interconnected dance keeps the inner Jovian system geologically active. Ganymede also influences the space weather environment around Jupiter. Its magnetic field carves out a mini-magnetosphere within Jupiter's massive one, shaping how particles flow and move. Could Ganymede host life beneath its icy shell? It's still unknown, but all the ingredients are there: liquid water, energy from tidal heating, complex chemistry. Whether it's a microbial ecosystem near the core or frozen organic molecules awaiting discovery, Ganymede may hold answers to how common life is in the universe. In the far future, this moon might even be a destination for exploration or habitation. Its large size, stable geology, and potential water sources make it a tempting base for long-term missions. In the next episode of Infinity Beyond, we'll descend into the volcanic fury of Io, Jupiter's most chaotic moon, and the most volcanically active place in the solar system.